Uh, Hi guys, I'm Yasira from the team of the academic committee. So here I'm for the discuss the first daily OSPE for the IPD module. So here this is a parasite. So this OSPE is from the parasitology. There's a picture showing a child with hepatosplenomegaly, and in this picture B showing his bone marrow aspirate, and it is given they are suspected to have a parasitic infection. So if we take the hepatosplenomegaly, from the lessons we have the parasitology, the most possible differential diagnoses are malaria or the visceral leishmaniasis, and also the schistosomniasis. But according to this bone marrow aspirate, this strongly suggests the leishmaniasis, because this picture is like you can see, it's a macrophage, and it has uh, amastigotes which has line and dot appearance. So it strongly suggests this is a leishmaniasis, and from this clinical picture we can find out it is a visceral leishmaniasis. So I can quickly go through this life cycle. So in the Leishmaniasis life cycle, we have two stages. First one is the promastigotes, which are the motile form, and the second one is the amastigotes, which are immotile, and those are in the macrophages of the reticuloendothelial system, which is includes liver, spleen, and bone marrow. So, which causes the clinical syndrome and makes the hepatosplenomegaly and bone marrow suppression, which causing the pancytopenia. So those mastigotes are causing the clinical disease, and then it goes to the sandfly, which is the intermediate host, and inside the sandfly gut, it converted into promastigotes, which have anterior flagellum, and it is the motile form of this Leishmania donovani, and the those are causing the infection to the man, which are the host. So when there is a female sandfly bite, these promastigotes are uh, deposits in the skin of the skin, or the near the punctured wound from the sandfly, and then those are getting uh, transformed inside the phagocytes by the macrophages, and therefore they are uh, transformed to amastigotes, and then again it causes the clinical disease. So let's go through to the questions again. So first question, identify the parasitic disease. So as we discussed, this is the Leishmaniasis, also visceral Leishmaniasis, is also called as Kala Azar, which is caused by the Leishmania donovani. And then second question, what is the stage of the parasite that can be seen here? So as we discussed, the stage is a amastigote stage, as this is from the bone marrow. So in bone marrow is also part of the reticuloendothelial system, and inside of the bone marrow we can see there are macrophages also. This is the picture of the macrophage, and so this is the macrophage, and yeah, this is the macrophage, and this is the nucleus of the macrophage, and these small tiny structures we can see here is the amastigotes. So if we enlarge this, so in the amastigotes we can see the LD bodies, all the Leishmania donovani bodies, so which is also called as dot and dash appearance here. So this is from the GMSA mediate GMSA stains smear from the direct microscopy. And then the next question, what is the characteristic appearance of this parasitic stage that enables the diagnosis? So if you can remember, the characteristic diagnostic method for the amastigote is the dot and dash appearance. So why it is this dot and dash appearance coming from is the dot represents the kinetoplast of the amastigote, which contains the mitochondrial DNA. This is the kinetoplast, which is also called as the dot, and the dash represents the nucleus. So these structures are seen inside the macrophages. So this wall structure is the Leishmania amastigote, and it is there are a lot of amastigotes inside the one macrophage cytoplasm, and this large structure is the nucleus of the macrophage. And actually we can't see the cytoplasm of the mastigote because it is like has the same color with the cytoplasm of the macrophage. And then the next question, what is the if there's a bone marrow aspirate was cultured, what is the parasitic stage observed in the culture? So if we go to the diagnostic methods of the leishmania, there are two main methods. The first method is the parasitological investigation, and the second method is the serological investigation. So in the serological investigations, we use serum, like we are finding out antibodies, antigens, and those things. So we are using ELISA, dipstick, these kind of assays. But in the parasitological investigation, we are using lesion samples. So as an example, in the cutaneous leishmaniasis, we are using slit skin smear, lesion aspirate, sponge biopsies. In visceral leishmaniasis, as in this case, we can use bone marrow aspirates, we can use liver aspirates, we can use splenic aspirates. So all of these are from the lesions. So in this picture, which is shown is it's from the direct light microscopy. So we have taken a bone marrow aspirate and I have sent it to direct light microscopy, so we can see the mastigotes. But the problem with this method is there can be low parasitemias. So it can cause false negatives. So actually the sensitivity is about 70% here. So therefore we have to increase the sensitivity by like resolving this low parasitemia. So we have to increase the number of the parasites. So for that we are using the culture method. So when we are culturing, these amastigote forms in the macrophages are converting into the promastigote form. So promastigote form we can see under the microscope. So what is this promastigote? It's seen like this. So it is the uh, extracellular elongated, and it has also has a nucleus and the kinetoplast, and then it has a anterior flagellum, which is this. It's anterior flagellum, nucleus, kinetoplast, and this is elongated structure. And so those are motile, as we discussed before, and this can be seen in the culture media, like as an example, NNN medium, Novi McNeil Nicoli medium. So detection of these promastigotes helps to confirm the diagnosis in the lab. And they are asking for in the fifth question, they are asking state two other symptoms that can be developed in this style. So as we discussed before, this visceral leishmaniasis, the progression of it is that it has a 2 to 6 uh, weeks of 2 to 6 months of incubation period, and after that there can be the parasite does spread via the bloodstream to the reticular endothelial system, which is liver, spleen, and the bone marrow, and then starts in the initial stages, which is giving the minor febrile illness, and it can be resolved spontaneously 2 to 3 days, but there might be hepatosplenomegaly and the anemia. So in this question they have given hepatosplenomegaly, so we have to write either one of these answers, jaundice, pancytopenia, or the fever. So answer should be jaundice, or it is obstructive jaundice because there is a hepatosplenomegaly. So it is enlargement of the enlargement of the hepatosplenom liver causing the compression of the bile ducts, causing obstructive jaundice, and also due to the bone marrow suppression, it causing the pancytopenia. And cause into anemia, leukopenia, and the thrombocytopenia. And if it is not treated, it can be fatal. And if it is treated, it can be cured, or it can be developed into post-Kala-Asa dermal leishmaniasis, which has a clinical picture like this. So as for a summary, here we discussed the clinical picture of visceral leishmaniasis, which is caused by Leishmania donovani, showing the amastigote form in the bone marrow, and it has the diagnostic dot and dash appearance. In the culture, the promastigotes are identified, and the key complications are including jaundice and pancytopenia plus fever, mild fever, and we have to make early diagnosis and treatment is critical unless it can be fatal. So thank you for listening, and we'll hope to continue this project for the more daily OSPE. So keep touch with us. Thank you.